In this video, I'm going to talk to you about the surface area of some three-dimensional shapes. The first one I'm going to look at is a rectangular prism. And the best way to think about surface area is to think about that shape as it's opened up, so that you're looking at its net. Thinking about this, and you may not necessarily need to draw the net to understand what it looks like. Some of you will be able to look at that and go, right, this rectangle, the surface is made, the rectangular prism, apologies, the surface is made up of two rectangles that are this size, this one and the back one. The side ones, two rectangles that are this side, this one and the other back one, and then the top and the bottom are the same size as each other. So technically you've got three rectangles and two of each. So as long as you know how it's made up, it's fairly easy, and you know the area of a rectangle is the length times its width. Some of you may find it easier if you do draw a basic net of a rectangular prism. Now, obviously this isn't to scale or anything like that, but just gives you an idea of which two are the same size as each other. So obviously this one and this one would be the same, this one and this one, and then this one and this one would be the same. Let's talk about the cylinder. A cylinder comprises of two circles and a curved surface that goes all the way around. And the letters that we use when we're talking about cylinder, we talk about the radius of the circle and the height of the cylinder. Again, something that might help you to work out what this would look like, or to come up with a formula for the total surface area of this shape, is to draw a net. So that's what I'm going to do now. So here we've got our curved surface area, which is around, and we can see that this is matching with the height of our cylinder. At the top, I have a circle, and at the bottom, I also have a circle. Now this edge here will wrap around these circles. So what we've got here is the circumference of a circle, which is either pi times the diameter, but seeing as we're dealing with circles and areas, we'll use the radius. So it's 2 pi r, where you have your radius here. Now let's work out each of the individual areas. We've got two circles. So the total surface area, TSA, of this cylinder is 2 pi, well, obviously the area of the rectangle, which is 2 pi r times h. So we say 2 pi r h plus two circles, area of each circle, pi r squared. This is the formula that you should learn. It will be given on your formula sheet, but it's the formula for the total surface area of a cylinder. Now you also could get questions on compound solids or composite solids, where there's a cylinder on top of a rectangular prism, for example. And what you need to do is consider what is the common side that's touching. So if I think about a cylinder sitting on top of a rectangular prism, there we go. The common side that's touching is this circle base here. So what I'm going to do is think to myself, I need to come up with a formula for the total surface area of this shape. I'm going to write it in words. So the total surface area of this shape would be the entire surface of the rectangular prism plus the curved surface of the cylinder only. We wouldn't add the two circles because this circle here is taken up by the area, the total surface area of the rectangular prism, and obviously that is counteracting by this one here. I'll write this in words. We have the total surface of the rectangular prism, total rectangular prism. Obviously, ideally I'd write it in a straight line. I don't have the room on the board at the moment, plus only the curved surface of the cylinder. Okay, because remember the common side, which I've coloured in, is taken already. We've added that already by using the total of the rectangular prism, which obviously counters for that one up there. And that really is an overview of surface area. Now what you need to be able to do is use these formulas and make sure that you can substitute values in for r, for h, and obviously know where your pi button is on the calculator.